Welcome to the Preparing Dilutions lesson. So today what we're going to be doing is, like I talked about how when companies or schools buy solutions from a supplier, they'll buy it in concentrated form. So if you think of it like, I don't know, there's like you can buy juice from the store where that's concentrated. It's like in the frozen aisle where it's like in a can. And anyway, so you take it home and then you add like 3 cups of water to it and then, stir it up and then you water it down because just drinking the liquid straight out of the can it would be really, really sweet and yeah, disgusting. So you would water it down and then you get a whole pitcher of juice and so forth. So it's the same idea. It's light, it's small and compact, and you don't have to pay as much because it's supposed to be cheaper because the water isn't in there, and you take it home and you add the water, so it doesn't weigh as much. It doesn't have all these extra costs. So if you think of like the solutions that we're getting for the lab and so forth, it's supposed to be cheaper because the product, the container is smaller. You don't need a whole bunch of trucks to transport these massive containers, have waters in them and so forth, and they're easy to store so that when you need them, they're concentrated. You just scoop out what you need and then you add water. And so it's like, scooping out what you need and making a glass for yourself instead of a whole pitcher. Okay. So anyway, that's what the concentrated solutions are going to be today. Something that, like that we bought from the supplier. And then, in a lot of cases, we don't need something so concentrated in our experiments, so we will water it down. So you need to dilute it. So this is like one of the formulas or concepts that you'll use all the way through university as well if you decide to pursue chemistry. So so it's a good tool to pick up and so forth. Okay, all right. So the idea of dilution. So you're reducing the concentration of a solution, and it's done by adding more solvent. So in a lot of our examples, it'll be water that's added, but we could add other solvents. Okay. I found some pictures online and I just added them just to kind of, if you don't know what I'm talking about, there's these frozen concentrated juice cans that you can buy. They're in the frozen aisle. And you go home, you take it home, put it in a pitcher. So here's the frozen juice. Okay, you open it up, throw it in, and then you pour 3 more cans of water in and mix it up, and then you make a whole pitcher of juice. So yeah, I'm not trying to promote these brands. These are the ones I could find online really quick. So that's kind of what you're doing today. You're taking the stock solution, watering it down, and then getting a certain concentration today. Okay, so now we're gonna move into dilutions. We're taking our stock solution and we're gonna dilute it so we can use it in an experiment and so forth. Okay, just I want to use an analogy here. So say you're making your, I don't know, family some drinks here. So say you have a package of, I don't know, iced tea. Okay, so you have a package of iced tea, and it comes in a certain size. So it'll have these 7 molecules in it. Okay, and what you're going to do is you're going to dump it in, and there's going to be some water up to this level here. Okay, you mix it up, and then right away I don't know, your sibling walks in and says, "I'm not going to drink that. That's gross. It's so thick and it's going to be too sugary." Okay, so then what you end up doing is you can say, oh, that you really like it this way, so you're going to drink it this way, and your sibling wants something that's watered down. So what you're going to do is you're going to get a new pack of iced tea and create a new one here, but you're going to add a lot more water. Okay. All right. So now if we're comparing these, your iced tea that you made for yourself is very concentrated. So because maybe you got a sweet tooth and you like it really sweet, where your sibling just likes it a little bit more on the bitter side, or just more, way more watered down. Okay. So in the end, though, you do still have the same amount of iced tea in your solutions here. So think of it as though when you dumped it in, there were 7, particles of iced tea. Okay, And then even in here, there's 7 particles of iced tea. But what makes it different is that you added way more water for your sibling here. All right, so, and then, you can imagine what it'll taste like. This will be really, really sweet because it's going to be really concentrated, where this one's watered down, so it's dilute. It's not going to taste as sweet. But in the end, the amount of iced tea that you used in both of them is the exact same. It's just that there's just a difference in the volume and the concentration of the iced tea. So again, the amount, concentration, those aren't the same thing. So the amount is literally you counting up how many particles of iced tea you put in. Okay, so 7 here, 7 there. But if I ask you how concentrated something is, then you would say, well, the one that you made for yourself is very concentrated. The one for your sibling is not, it's dilute. Okay, so concentration is not the same here. That's different. You can also see that the volume is different. So concentration is not the same. So I don't know, we'll call this concentration of 1 is not the same as concentration 2. Hopefully you can see that the volume is not the same as the second volume, but the amount is the same. Okay, so let's call that N. The amount is the same for both of them. Okay, so you added in the same size package into both of them, and we're going to assume they have exactly 7 molecules in there. And so basically when you dumped it in, they still have the same amount of iced tea, but you just don't have the same volume or the concentration. Okay, so concentration and amount are not the same. I grabbed the definitions from the other day when we looked at Introduction to Solutions. So again, remember concentration is the how much of the iced tea that you added compared to the volume of the solvent. Okay, so the quantity of iced tea that was added compared to the volume. So the quantity is the same, right? We know the amount is the same, but the volume is different. And since the volume is different, therefore the concentration is different. So again, the one on the left is concentrated because you have a large amount of solute compared to the volume. Okay, and the one on the right is dilute because now you compared to how much water, like if you can see all those water molecules, you don't have as much solute compared to how much of the water molecule, the solvent. So that's why it's dilute. So like this picture was attached to the notes as well. So this was considered to be dilute. This was considered to be concentrated. In this case here, the volume was the exact same, but this is more concentrated because you can think of it as you really, really like sugar. So you added a double packet of the iced tea, okay, and mixed it in there. And then your sibling likes to have it this dilute, okay? So maybe like you followed the instructions for this one, you had 1 pack for that much water, where you really like stuff sweet, so you dumped in a couple packages in here. So it's way more concentrated. The volume is the same, but the amount of solute is different, okay? In this case here, the amount is the same, one packet, but the volume is different. So again, you can get differences in concentration where you change the volume or you change the amount again, okay? But what we are doing today is we are, taking this scenario here where we have, 1 pack of iced tea goes in, okay? And then we are going to change the volume and then figure out what the new concentration will be. Okay, so we're not going to do this one where we end up dumping more and more of the solute in. Okay, we're going to have a certain amount of solute going in, so we're not going to change the amount, so that'll stay the same, but we're going to see the effects of the volume and the concentration and see how that changes. Here is one more picture, just in case you just need to see just another visual picture here. So again, you have your iced tea, it'll be darker in color, right? And then you're going to dump in water and it'll be lighter. Okay, so so you can see that there has been a dilution here. But again, you had just that 1 pack of iced tea placed in here, 1 pack placed in here, but way more water in this other one. So if you wanted to Again, if we were looking at one little spot right in the solution here, this is what you would see. You would see way more iced tea um, molecules in that certain area compared to the water, where if you look at that one little tiny spot in this one here, you would see that there wouldn't be as many iced tea molecules in that one spot because they will be spread out all the way through the greater volume of water here. So hopefully now you understand the idea of dilutions. We can develop an equation here that we can use to calculate today. So again, we know this formula from the other day for calculating the amount concentration of a solution. So we need the amount of divided by the volume is the concentration. We found from the dilutions here that we know the amount is not going to change. We are just going to change the volume, which will change the concentration. Okay, so we can set the amount of the concentrated equal to the amount of the diluted here. So like in this example here, here's the concentrated and here's the diluted. So we can set the amounts because if you rearrange this, so you move this over, so if you move this over here, you end up with a formula that's C times V like that for the amount. So we can set the amount of the before mixing or diluting and the amount after equal together. Okay, so the amount of concentrated, so the amount does not change, okay, will equal the amount that's diluted because in the end, you'll have still the same number of particles in the solution regardless of how much water you dump in. All right, so then it comes to this formula here. So the little C's, the subscript C's represent the initial concentration. Okay, so if you are looking at the initial concentration, it will be the one that's more concentrated. And then afterwards, once you dump the water in, you'll get the diluted solution. Okay, so the D for diluted. But again, if you feel more comfortable using like 1 and 2, okay, so you start with 1 and then you go to 2, again, that's fine as well, okay? And then, so if you want to look at them specifically here, this is the concentration of the concentrated solution. This is the volume of the concentrated solution. This is the diluted concentration. This is the volume of the diluted solution, and so forth, okay? All right, so let's get to an example here. What is the final concentration of a 250 milliliter 16 mole per liter nitric acid solution that is diluted to 4.5 liters, okay? So again, if you want to make a visual diagram, you have, solution, the concentrated solution, okay? So I don't know, we can call it 1, and then it becomes 2. So what you're doing here is, so if we're doing given here, I guess, so we have our 250 milliliters of nitric acid. Okay, and then we're diluting it, so let's say we're adding water, okay? So yeah, if we're diluting acid, we would add water. So we're using pure water here, and then so we want to know the final concentration here. Okay, so what is the final when we're diluting it to become 4.5 liters. Okay, so we started off with like 250 milliliters, which is like a cup if you're baking. Okay, and then you ended up with like 4.5 liters, which is like 3 milk bags and a little bit more. Okay, so we're watering it down quite a bit, and but like this 16 mole per liter concentration of nitric acid is very, very dangerous to use. Okay, so again, like you'd open the container up and you can instantly smell the acid, and it's not good. Like it would start irritating your lungs and your skin and so forth, and your eyes. So we don't want you using stuff like that in high school labs. So we're going to dilute it down, and you can hopefully see that's quite a bit. So you're going from like a cup to 4.5 liters, okay, at the end, okay, so you're watering it down quite a bit. So with this process here, I want you to tell me then, what is the new concentration, okay? So because it's going to get watered down, the concentration will be lower than 16. So that we're going to go about finding that now, okay? So again, the required is the diluted concentration. Okay, so what we're going to do here is we need to work in the same units. So see how concentration is in liters, right? So we have this one here that's in milliliters, so we want to convert that over right now. So let's change it to liters by dividing by 1,000, like that, okay? So again, a reminder is you're dividing by 1,000 to get to liters. Okay, so now that you have that information, our plan is, well, you know that the amount that you started with, which is 1, so you can think of this as like the concentrated, and this is the diluted, or 1 and 2, whichever. You know that the amount of the concentrated is still the same. Well, the diluted will still be the same, okay? Because I'm not adding more nitric acid into here, okay? All I'm doing is adding water, okay? And so that you are not changing the amount of nitric acid that is in here. So like NO3, the NO3, okay? So the amount of this is still the same, but what's going to happen is the concentration will change because you're going to dilute. So since the amount is the same, we know that the formula, okay, because again, this is the formula. In order to get amount, you take concentration times time. So the concentration of the concentrated times the volume of the concentrated is equal to the concentration of the diluted times the volume of the diluted. So that's the formula now that you're going to be using today. And so there's a few different ways that you can do this. You can add your information in here and then solve it, or you can rearrange this formula first if you want to use the formula method. So I'm going to start by just adding all the information into the formula, and then I'm going to solve it. Okay, and then I'll show you how to solve it right away. Okay, so we have the initial concentration, or the concentrated concentration, which is 16 mole per liter. And then you're going to multiply by the concentrated volume, which is 250 milliliters, but we're going to use the liters. Okay, and then the concentrated diluted, we don't know, but we know the volume of the dilution ends up being 4.5 liters at the end. Okay, all right, so from there you should be able to solve your way. So I'm just going to move this over. So it's just like math. Right now it's multiplied, so I'm going to divide it away. So you have 16 mole per liter times 0.25 liters, all divided by this 4.5 liters. And once you calculate that out, it'll give you the diluted concentration. Okay, and people that use the unit analysis method, I will show you how to do that next, okay? But just watch and follow through with this so that you have a backup plan in case you just kind of forget what to do with the unit analysis. All right, so this in the end will be mole per liter, okay? Because like these 2 liters will cancel out, but that still leaves mole per liter. Okay, so that's the concentration. It keeps going on my calculator here that you will get for the diluted concentration. So you went from 16 down to less than 1 mole per liter. Okay, so that's something still like you could still, like if you get this on yourself, you can still cause irritation on your skin and cause holes in your clothing and so forth. So that's why we're still going to wash our hands and take precautions. But it's, you're not going to be dealing with something like this, okay? All right, just to finish up here, we're just looking at how many digits. So I see 2 here, I see 3, and I see 3. So we're going to get this down to 2 digits. So 8, 9. Okay, so your final statement here Okay, so again, this is key. A lot of people will get to the point where they can calculate things without thinking and get the right answer, but they can't explain what it is that they just found. So make sure you can do that. Okay, so go back through what is it that you had to find? What is the final concentration, right? With all this information. So you would say the final concentration okay, of the nitric acid is 0.89 mole per liter. Okay, so again, you started off with something very concentrated. You had, a cup's worth of it, and then you added water, and you ended up with 4.5 liters of water. And then from there, you have to tell me, okay, so therefore, how much did the 60 mole per liter get watered down? So what's the new concentration? So we found it to be 0.89 mole per liter. Okay, so I'm going to go back here and show you another way to go about calculating this using a formula. So what I did was I took our original formula for dilution here and I plugged all the numbers in and then I solved it. What you could do if you prefer to solve it right away, so you can write the formula that you start with. Okay, and then you know that you have to calculate the diluted concentration, this one here. So what you can do is you can rearrange the formula right now. So just boot the volume over. Okay, and then you end up with the diluted concentration equals. So again, if you want to rearrange it. Okay, and then you can get to here and then you just plug everything in and it's pretty much this step here and then you can calculate your answer. So if you prefer to just rearrange the formula first and then plug stuff in, you can. Otherwise, just take this formula, plug everything in, and then rearrange with the numbers in there. You can get to your final answer that way as well. So with this formula method, you may have found, writing little, C and then a little c and then, writing these letters may have been a little bit annoying. So what I'm going to do in the next example is I'll use the numbers and then you can kind of decide which one you prefer. So like that. So instead of writing C and D and so forth, you can just go 1 and 2, 1 and 2. Okay. Again, I prefer to use the 1 and 2 method, but yeah, so if you prefer the letters, just because then you know, okay, concentrated goes here, and the diluted goes here, or you can think of it as what you start with goes here, what you end with goes there, whatever works. Okay, but I'm going to use the number 1 for the next one. All right, for now though, I'm going to show you the unit analysis method. Okay, so again, I'm going to set everything up like here is my initial solution, and then I'm going to add water to it and then get a diluted solution here. Here's all the information given, and I need to find the diluted concentration. Analysis method, what we're going to do is we're going to find the concentration of the diluted form. Okay, by starting with the concentration of the concentrated form. Okay, and again, we are trying to get to the moles because the moles is the same for both. So we're going to get from to the moles by using concentration and volume here. Okay, so here's the concentration value of the here's the concentration value of the concentrated solution. Okay, and then we're going to multiply by the volume here. Okay, we're going to use volume, and then which way do we use it? Well, we want liters to be up at the top for this one. Okay, so when we put these together, we'll get moles. Okay, so when we put these together, we'll get moles. Okay, once we know the moles of the initial solution here, then all we have to do, because remember concentration is mole per liter. Okay, so in the next step, all you're going to do is now divide by the volume of the new solution. So again, we don't want, oops, this should have been a 1, sorry. We don't want the liters to be at the top because it'll be mole liter, right? We don't want so we don't want to put 4.5 here, because if we do that, remember these two canceled out. Okay, so then you're going to end up with the unit mole liter, and that's not a unit for concentration. We need mole per liter like that. Okay, so what we're going to do here is we're going to divide. So it's about, just kind of knowing what the unit should look like. So we know, oh, in this step here, for the new volume, we need to divide that. Okay, so we go through, we're going to go 16 times 0.25, and then divide by 4.5. And here is the concentrated or here's the concentration for the dilute solution here. Okay, all right, and then we need 2 digits, 0.89 mole per liter. Okay, and a therefore statement. Okay, and the key word is final concentration. So you need to be saying what type of concentration it is. Okay, so is it the initial concentration, is it the concentrated concentration, or is it the dilute concentration? So if you wrote final concentration here, that's good, or you could have written the diluted concentration. Okay, both are sufficient for the keywords, but it's 0.89 mole per liter. Here's example 2. So if we have 45 milliliters of water and it's added to 250 milliliters of this 0.75 mole per liter solution of potassium sulfate, what will the concentration of the diluted solution be? So again, if it helps to draw a diagram, do that. So think of it like, you have a container and you are, there's 1, there's 2, okay, so this is like before, number 1 is before and the other one's after. Okay, so before and after, they are the same containers, okay? All right, so you start off with, so we're looking at what's given. So if we have 45 milliliters of water is added to the 200, so you have to watch the wording here. So this, so again, I'm going to write 1 and 2 again for before and after. So we have a volume of 250 milliliters, okay, which we're going to write as 0.25 liters, switch to liters, and the concentration is 0.75, okay, so you have to watch the wording here. All right, so we are adding 45 milliliters of water. Okay, so now after that, what do we have? Okay, so it's asking us to find the diluted concentration, so that's the question mark. Okay, so there's our required piece, or I'll write that in a sec. All right, but then the volume, what's the volume, the new volume here? Okay, so in the previous example here, it said when 250 mils of this 16 mole per liter nitric acid is diluted to 4.5, it told you what the volume was at the end. Here in this question, it is telling you, okay, you have 250 milliliters of 0.75 mole per liter of potassium sulfate solution. You're adding 45 to it. So it's not telling you what the new volume is. So you have to just kind of be careful with that and then make that adjustment. So you had 250 and you're adding 45 to it. Okay, so you end up with 295 milliliters, okay? So you just got to be careful, watch the wording, and then now you can convert this to liters. So we work in liters, okay? All right, so now that, again, I recommend drawing the diagram to kind of help visualize stuff, and then use graphs here to kind of organize your thoughts, okay? So here's all the given stuff. We have the 2 volumes, we have the initial concentration, so now we have to find the final concentration. So again, we're going to start off with the formula method first. Okay, so our new formula that we are using today, and I'm going to change this. So here, changing the C and D's. I'm going to change the C and D's to 1 and 2 instead. Okay, it's a little easier to write these numbers. Okay, so this is what we had before. This is what we end up with after, okay? All right, so again, if you want to rearrange this first and then plot the values in, you can do that, or you can just put all the numbers in and then rearrange after. I'm going to rearrange the formula first, okay? So I need C2, the concentration of the second diluted solution, to be by itself. So I'm going to boot this volume out of there and put it on the other side. So right now it's multiplied on that side. So to move it, you are going to divide it over. And here is the new formula that you're going to work with today. All right, so let's plug everything in. So C2, the initial concentration was 0.75 mole per liter. And we're going to multiply it by the initial volume, which is in liters. Make sure to change that over. Okay, and a good way to make sure, like to check, I guess, to remind yourself to check, is to see if you can cancel out these units here. Okay, and then divided by the second volume, the total volume that we ended up with, 0.295. So again, make sure, read the instructions carefully so that you don't get tripped up on that. So again, these would cancel out. That would leave moles at the top, and then I divide by liters at the bottom to end up with mole per liter for the unit, so we're good. All right, so let's calculate this out. Okay, and then we'll just carry a few extra digits. Okay, and then we end up with mole per liter, which is the right unit, and I'm just checking to see how much I round up by. So I have 2 digits here, 3 here, 2 there. So we need 2 digits in our final answer. So the concentration is 0.64 mole per liter. All right, and our therefore statement. Therefore, okay, let's look for the keyword. What is it that we had to find? We had to find the concentration of the diluted solution, or you could say the final concentration, I guess. But I guess diluted solution is more specific. So the concentration of the diluted solution is 0.64 mole per liter. All right, so that was the formula method. Okay, so again, use the one that you're more comfortable with, and I'm going to show you now the unit analysis method. Okay, so here's example 2 again. So we're going to go through and write out all the things that are given and required, just like the formula method. Okay, so again, read through carefully and remember that you have, you're adding 45 milliliters to the solution to get to the diluted solution. So if it was added to the 250 milliliters, 0.75, so that's the initial amount, and we're adding 45, so that means we have to add 45 to 250 to get a total volume, final volume of 295 milliliters, okay? Make sure to convert everything to liters, and then here we go. All right, so with the unit analysis method, remember that you are going through and doing the analysis and the solution solve step at the same time. Okay, so our goal here is to find the concentration of the second diluted solution. Again, so we're going to take a look at our little map that we're going to use here. So we need to use concentration and volume to get to the moles. And once we get to the moles, then we're just going to go moles divided by volume to get to the concentration of the final solution. Okay, so we start out with the initial concentration. So 0.75, so stack up the units. Okay, all right, and then we're going to use the volume of the initial solution. So again, we just got to determine which way to stack that. We don't want the liters to clash, so we have to have the liters up here. Okay, so we're going to go 0.25 liters, and if it bothers you that there's nothing here, just put a 1, okay? All right, and then, so once we do that, that's going to get us to, you know, the liters will cancel out, and now you have moles, which is good. So you're on the mole island. Okay, so you're on this mole island now. So you went from here to here to here. So now you want to go and get the concentration. So now we're going to use the other volume here, 295. And again, we got to decide which way to stack that. So the liter's already gone. We have moles here, and the concentration units are mole per liter. So we want the liters to be at the bottom here. Okay, all right, so now we know everything's stacked the way it needs to be. So let's calculate the top values together, okay, and then divide it by the 0.295 at the bottom. And we end up with mole per liter. Okay, so if we check up here, that's what we had above before as well. All right, and round it to 6.4 to 2 digits, and then make your final statement. Okay, therefore the amount, if you want to get fancy here, use amount concentration because it's mole per liter. The amount concentration of the diluted solution, and again, if you want to get really fancy, of what sample is it? Potassium sulfate, okay, is 0.64 mole per liter. Okay, so again, it's always good to be thorough. Please don't be abbreviating things in your final statement and just writing concentration is. Okay, make sure be specific. The concentration of the diluted solution, the final solution, and so forth. Okay, all right. So hopefully that was enough of just examples for you to study off of. So again, just one warning here, like with example 1 was nice and straightforward. It told you, okay, this is what we had at the beginning. Then we do this amount here or this volume here, find the initial or final concentration, right? So it kind of told you explicitly what to do. But here it kind of, told you that we dumped in some water, but it didn't tell you the final volume. Okay, so don't just kind of look at it and go, oh, I see 3 numbers. That one must be C2 or V2. That one's V1, C1. Okay, kind of look through, make sure read it carefully so you know exactly what it's saying, because sometimes you need to find the final volume or adjust some of the numbers and so forth. Okay. All right. So yes, go please practice the practice questions. Okay. Again, I'm giving little checks here and there to see how you can do questions, but you want to get ready for next year, so you want to be doing all the questions to look at all the different scenarios, so you're prepared and ready for Chem 12.